Circle. Introduction of circle and its contains 3 possibilities of a circle and a line in a plane, 3 possibilities of 2 circles lie in a plane, some theorems related to circle. Hello students, today we will be going to learn a very important topic, circle. We have studied what is a circle in previous class. We have studied how a boy draws circular boundary to play. We found that while drawing a circle, length of a rope is constant. A circle is the locus of points in a plane which are at a constant distance from a fixed point in that plane. The length of a circle is called circumference. A fixed point is called center of a circle, and a constant distance from center to the circumference is called radius. Diameter of circle is twice the radius. We all know chord, segment, arc and sector. As circle is a simple closed curve, it divides the plane into 3 regions. Therefore, any point P can lie in the exterior of circle or on the circle or in the interior of a circle. Let us now examine the different situations when a circle and a line are given in a plane. So, let us consider a circle of center O and a line PQ. There can be 3 possibilities. 1. The line PQ and the circle have no common point. In this case, line PQ is called a non-intersecting line with respect to the circle. 2. There are 2 common points, A and B, that the line PQ and the circle have. In this case, we call the line PQ a secant of the circle. And the third possibility, there is only one point A, which is common to the line PQ and the circle. In this case, the line is called a tangent to the circle. If 2 circles are in a plane, there arise following possibilities. 1. Concentric circles. If 2 circles have same center and different radii, they are called concentric circles. 2. Congruent circles. 2 circles having equal radii are called congruent circles. Circles of center O and center P have same radii of 2 cm. 3. Intersecting circles. 1. 2 coplanar circles having 2 points in common area called intersecting circles. Circles of center O and center P have 2 common points A and B. 2. 2 coplanar circles intersecting each other in one point are called touching circles. These are 2 situations in which circle of center O and circle of center P touch in a point. We know chord in a circle very well. A line segment joining any 2 points of the circle is called chord. And if a chord passing through center of the circle, we called it diameter. The perpendicular drawn from the center of a circle to a chord bisects the chord. Theorem. The segment joining midpoint of a chord and the center of circle is perpendicular to the chord. Let us draw a circle of center P and a chord CD. Now M is the midpoint of CD. Now we have to prove this segment PM is perpendicular to chord CD. To prove, we draw segment PC and segment PD, which are also radii of circle. We can see 2 triangles, triangle PCM and triangle PDM. By SAS test, we can prove easily that triangle PCM and triangle PDM are congruent. Hence, angle PMC and angle PMD are also congruent. But angle PMC and angle PMD are angles in linear pair. Their sum will be 180 degree. Therefore, twice of angle PMC is equal to 180 degree. As angle PMC and angle PMD are congruent and hence angle PMC is of 90 degree. As angle PMC is of 90 degree, segment PM is perpendicular to segment CD. Hence, we proved. Theorem. Chords which are equidistant from the center of congruent circles are congruent. In this theorem, we have given two congruent circles with center P and Q. Chords AB and CD are equidistant from center P and Q of circles. Therefore, segment PM perpendicular to segment AB and segment QN is perpendicular to segment CD and PM is equal to QN. We have to prove chord AB and chord CD are congruent. Now in right angle triangles, triangle PMA and triangle QNC, hypotenuse PA and hypotenuse QC are congruent. Side PM and side QN are also congruent. Therefore, by hypotenuse side theorem, triangle PMA and triangle QNC are congruent. Therefore, by CSCT, segment AM also congruent with segment CN. Hence, AM is equal to CN. But AM is half of AB and CN is half of CD. By this relation, we get chord AB congruent to chord CD. Hence, we proved chords which are equidistant from the center of congruent circles are congruent. Theorem. Congruent chords of a circle subtend congruent angles at the center. We have given a circle with center O and chord PQ is approximately equal to chord RS. We have to prove angle POQ congruent to angle ROS. To prove, let us construct OS, OR, OP and OQ. Now, after construction, we have triangles POQ and ROS. In triangle POQ and triangle ROS, we get three pairs of congruent sides. Therefore, by SSS test, both triangles are congruent and hence, by CACT, angle POQ and angle ROS are also congruent. Hence, we have proved congruent chords of a circle subtend congruent angles at the center. Summary. In this lesson, student, we have seen introduction of circle and its contents, three possibilities of a circle and a line in a plane, three possibilities of two circles lie in a plane, and some theorems related to circle. So that is all in this lesson, student. Learning geometry is a great fun. So keep learning.